So let's just reinforce the difference between vector form, parametric form, and Cartesian form. And I'm using the previous example to do this. So firstly, we have r equals negative 3i plus 6j plus 5k plus k lots of ai minus 4j minus 4k. Really don't like the use of the k, but it's on the formula sheet. I personally would be using lambda. But anyway, we will go with what's on the formula sheet. So that is in the form of R equals A plus KD. So it is our vector form, remembering that that is on your formula sheet. So in this case, our A would be negative 3i plus 6j plus 5k. And our D would be 8i minus 4j minus 4k. So this here is our vector form. Now parametric form, any point on the line is given by, so our x is going to be negative 3 plus 8k, reading from that vector equation. Our y is going to be 6 minus 4k, again from the vector equation. And our z is going to be 5 minus 4k. So they're our parametric equations. Note that they're in the form of x equals a1 plus d1k, y equals a2 plus d2k, and z equals a3 plus d3k. Now for Cartesian form, we have to start with our parametric form. Rearrange to get k on its own. So this will be x plus 3 over 8. So here we have k equals y minus 6 divided by 4. Now you could express that as 6 minus y divided by 4. So distributing the negative throughout the numerator. And the last one will be k equals z minus 5 over negative 4. And again, we could rewrite that as 5 minus z divided by 4 by distributing the negative. I'm not going to do that though because I want to show the reference with the formula on your formula sheet. So we have k equals x plus 3 over 8, which equals y take 6 divided by negative 4, which equals z take 5 divided by negative 4. And if you look at your formula sheet, you have x minus a1 over d1 equals y minus a2 over d2 equals z minus a3 over d3. So that's on your formula sheet. So in general, for a line that passes through the point x, y, z, which equals a1, a2, a3, and parallel to the vector d, d1i plus d2j plus d3k, the vector equation is r equals a plus kd. Parametric form is x equals a1 plus d1k, y equals a2 plus d2k, and z equals a3 plus d3k. Our Cartesian form is x minus a1 over d1, y minus a2 over d2, and z minus a3 over d3. Let's finish with an example. The vector equation of a line is given by r equals 8i plus 2j minus 3k plus k lots of 3i minus 4j plus 2k. Convert the vector equation into parametric form. Well, our x is 8 plus 3k, just reading across. Our y is 2 minus 4k, and our z is minus 3 plus 2k. Again, just reading across your vector equation. Part B, express the parametric form of the line as a Cartesian equation. So you have x equals 8 plus 3k. That means k is x take 8 over 3. Y is equal to 2 minus 4k. So k is y minus 2 divided by negative 4. And z equals negative 3 plus 2k. So k is z plus 3 all over 2. So they all have to be the same because they all equal k. And I personally would like to distribute the negative. So I would go x minus 8 over 3 equals 2 minus y over 4 equals z plus 3 over 2. And that there is your parametric form.